On November 20th, 1943, at Tarawa Atoll, 5,000 United States Marines prepared to assault a beach defended by 4,500 entrenched Japanese soldiers. The landing craft carrying them towards certain death had been designed by a Louisiana lumber dealer with an 8th-grade education, built using techniques he'd learned constructing shallow draft boats for bootleggers in the bays. Naval architects had mocked his design. The Bureau of Ships had rejected his proposals 3 times. His boats had no keel, carried their propellers in exposed tunnels, and featured a flat bottom that violated every principle of naval architecture taught at Annapolis. Senior admirals called them Higgins' folly. Yet, these ridiculous plywood boxes would survive shore bombardments, coral reefs, and Japanese torpedoes better than vessels designed by graduate engineers with decades of experience. By 1945, Andrew Higgins' LCVP, the landing craft vehicle personnel, had participated in every major amphibious assault of the war from Sicily to Normandy to Okinawa, and Dwight Eisenhower would call Higgins the man who won the war for us. This shouldn't have worked, but Higgins wasn't building for naval theory. He was building for swamps, sandbars, and desperate situations where traditional vessels got stuck and men died waiting. That perspective, born from commercial necessity rather than military doctrine, produced the most effective amphibious assault vehicle in history in 1938, when the U.S. Marine Corps began seriously planning for amphibious warfare. Standard military thinking emphasized deep draft displacement holes. The Navy's Bureau of Ships designed vessels based on principles established by centuries of naval architecture: keys for stability, protected propellers for durability, V-shaped hulls for wave handling, and substantial draft for control. Their prototype landing craft drew 4 ft of water fully loaded, required a beach gradient of at least 1:30 to avoid grounding, and cost $12,500 per unit to manufacture. The Bureau's lead designers argued that shallow draft vessels would be uncontrollable in surf, that exposed propellers would be destroyed by debris, and that flat bottoms would pound themselves apart in waves. They had mathematics, wave tank testing, and centuries of shipbuilding tradition supporting their position. When Andrew Higgins submitted his Eureka boat design, a flat-bottomed shallow draft craft originally built to navigate Louisiana's oil fields, Bureau engineers rejected it immediately. Their analysis noted that the design violated fundamental principles of marine architecture, had inadequate directional stability, and represented an unacceptable risk to personnel and equipment. Marine Corps planners, meanwhile, looked at another problem entirely. They'd studied every amphibious assault from Gallipoli forward and identified a consistent killer: the gap between where boats could go and where beaches began. Men drowned, wading through surf in full combat gear. Equipment sank. Troops bunched into kill zones while crossing exposed beaches. The Marines needed boats that could drive right up onto sand, disgorge troops dry-shod, and reverse off into deep water. Traditional naval architecture couldn't deliver that. Standard landing craft grounded 50 to 100 yards offshore, forcing troops into chest-deep water while under fire. The contrast crystallized in 1940 during landing exercises at Cababra, Puerto Rico. Navy-designed boats grounded 75 wide from the beach. Marines waited ashore for 20 minutes, exhausted before reaching dry land. One mock defender with a machine gun killed an entire platoon in the surf. Meanwhile, a single Higgins boat, borrowed for testing against official protests, drove straight onto the sand, dropped its bow ramp, and disgorged 36 combat-loaded Marines in 15 seconds. The Marines were sold. The Navy Bureau of Ships was furious. The secret was in what the Higgins boat deliberately sacrificed for what it gained. The LCVP measured 36 ft3 in long with a beam of 10 ft10 in, and drew exactly 2 ft2 in at the bow, 3 ft at the stern when fully loaded with 36 troops or 8,000 lb of cargo. That shallow draft came from a completely flat bottom. No keel, no V-hull, just a slab of wood running from bow to stern. Naval architects considered this amateurish. Higgins considered it essential. What actually mattered was approaching beaches. The Pacific War would be fought across coral reefs, sandbars, and tidal flats where water depth measured in inches. Tarawa's reef extended 500 wide offshore with water barely 3 ft deep. Saipan's beaches featured underwater obstacles in 2 ft of water. Normandy's tidal range meant boats needed to work in everything from 12 ft to 3 ft of water. The Higgins boat could operate in any of it. Its flat bottom distributed weight evenly, letting it slide over obstacles that would gut conventional hulls. When it grounded along its entire length, not on a single keel that could snap. The tunnel drive system scandalized naval engineers even more than the flat bottom. Traditional propellers hung below the hull in protective cages or apertures cut into the keel. Higgins mounted his propeller in a semicircular tunnel carved into the bottom of the hull, with the propeller shaft protected by a skag above it. The propeller protruded barely 6 in below the hull bottom. Bureau engineers predicted it would cavitate uselessly, provide no directional control, and tear itself apart on the first submerged log or coral head. The reality of combat showed something different. At Tarawa, Higgins' boats crossed coral reefs that ripped the bottoms out of conventional landing craft. The tunnel protected the propeller, while the flat bottom slid over coral heads that would have gutted deeper draft vessels. When boats inevitably struck obstacles, the impact occurred on replaceable wooden planking, not on expensive propulsion systems or structural members. Crews learned they could hammer a damaged bottom mostly flat, stuff Kapok life jackets into the holes, and keep operating. One LCVP at Tarawa took a 75 shell through the bottom at the waterline, stuffed the hole with a May West life preserver, and completed 6 more trips before returning for proper repairs. The construction method looked equally suspect. Higgins built his boats from marine plywood over white oak frames using techniques borrowed from Chris-Craft pleasure boats rather than naval specifications. The Navy preferred steel. Steel was strong, durable, and proper. Plywood was for dingies. Yet each LCVP weighed 18,000 pounds fully equipped, half what an equivalent steel boat would weigh. That reduced draft, let smaller engines push them faster, and meant 2 men could manhandle a beach boat back into the water. When a shell or torpedo struck plywood, it punched a clean hole that could be patched. When it struck steel, it created jagged tears that required welding. More importantly, Higgins Industries could build plywood LCVPs at the rate of 700 per month using semi-skilled labor. Steel boats required shipyard facilities and skilled welders the Navy didn't have enough of. The bow ramp represented the final heresy. The Bureau of Ships insisted on boats with solid bows and side-mounted ramps or nets. Their reasoning was sound. A bow ramp weakened the structure and created a massive point of vulnerability. Higgins argued that frontal egress was faster, safer, and more practical. The Marines agreed. When you're under fire, climbing over the side means exposing yourself. A bow ramp let an entire squad charge straight onto a beach in seconds. The structural weakness never mattered. If enemy fire was heavy enough to destroy the ramp, the boat was already in trouble. And in nearly 24,000 Higgins boats built, catastrophic ramp failures were essentially non-existent. The Higgins boat's reputation was forged in the hell of Tarawa, November 20th to 23rd, 1943. The Japanese had fortified Batio Island with 500 pill boxes, 40 artillery pieces, and 4,500 veteran troops who expected the assault. The island's coral reef extended 500 to 800 wide offshore with water depth varying from 1 to 3 ft depending on tide. Navy planners predicted the tide would peak at 5 ft, enough for Higgins boats to clear the reef. They were catastrophically wrong. The tide peaked at 3 ft. Conventional landing craft of the first wave grounded on the reef 700 wide from shore. Marines climbed out into chest-deep water and waded toward the beach under murderous fire from precited machine guns and artillery. The 2nd Battalion, 8th Marines, lost 35% of its men before reaching the beach. One company landed with 142 men. 92 became casualties in the surf. Bodies floated in windrows along the reef. Marines called it the longest 700 wide in the Corps' history, but 87 LCVPs participated in that assault and their performance determined who lived. Where the reef was shallowest, barely 2 ft of water, only Higgins' boats got through. Their flat bottoms scraped over coral heads that trapped everything else. Their tunnel drives kept propellers clear of obstructions. Their shallow draft meant they could push to within 20 yards of the beach, even at low tide, cutting the killing zone from 700 wide to a short sprint. Companies landed by Higgins' boats in the assault second wave suffered half the casualties of units forced to wade from the reef. Lieutenant William Dean Hawkins, leading a scout sniper platoon, reached the beach in an LCVP that crossed the reef at exactly 9:17 on November 20th. His after-action report noted, "Boat drew perhaps 2 feet, scraped coral twice. Both times the bottom made an awful noise, but we kept moving. Beached in 212 ft of water, ramp dropped. We were on dry sand in 10 seconds. Hawkins' platoon destroyed 4 Japanese bunkers in the first hour." He was killed the next day, but recommended for the Medal of Honor, which was awarded posthumously. His report specifically credited the LCVP with his platoon survival. "If we'd been in one of those Bureau boats, we'd have drowned before we fired a shot." The Japanese weren't prepared for boats that could cross their carefully planned obstacle zones. Rear Admiral Kai Shibasaki, commanding the Tarawa garrison, had positioned his defenses, assuming landing craft would ground at the reef edge. His pre-sighted artillery covered the surf zone from 500 to 100 wide out. The few Higgins boats that reached the inner zones found lighter resistance. The Japanese had allocated fewer weapons to close and defense because they didn't think boats could get there. After the battle, captured Japanese reports expressed confusion about American